we will be talking about probability rules. Rule number one. For any event, EI, E sub I means E1, E2, E3, it depends. I mean, just counting the events. The probability is going to be between 0 and 1, and we already talked about that one. Any probability is always going to be between 0 and 1. Rule number two. The sum of the probabilities of EI is equal to 1. EIs are the outcomes. Very simple example here. If you roll or flip, let's say, flip the coin once. If you flip the coin once, what are the possible outcomes? Sample space. Either you're going to get head or you're going to get tail, right? You can call these are E1 and E2 basically. So E1 is the head, E2 is the tail. So if I ask you what is the probability of the head, what is the probability of getting E1, you're going to tell me 1 over 2. What is the probability of getting E2, which is the tail, is going to be 1 over 2. These are all of the possible outcomes, by the way. If you add all of these outcomes, you're going to get 1. So the sum, so PE1 plus PE2 is equal to half plus half, which is 1. So EI is the ith outcome. This is important. Little I is the is part of the sample space. Rule 3 is the addition rule of the individual outcomes. Individual outcomes. This is important. Individual outcomes. So if you have like an event, let's say EI contains 3 events, then what is the probability of EI of that event? It's going to be the addition of these events, individual events. PE1 plus PE2 plus PE3. Example. Suppose that we are rolling a die. Rolling, I don't know, double L or 1L. Rolling a die. So, what is the sample space? Sample space is getting 1, 2, 3, 4, 5, 6. Right? 1 out of these guys. If I define the event, let's call it E1, the event is going to get an even number, getting an even number. So what is this event? What this event contains? E1 contains 2, 3, 2, 4, 6, right? And basically you can call them like E2, E4, E6 if you would like, little e. Let's call them. So let's call these E2, E4, E6. Just give them names. And if I ask you what is the probability that you're going to get an even number, so you're looking for probability of E1. So either you're going to tell me, okay, how many elements do we have? We have 3. Using classical method over 6, which is half. Yeah, that's correct. That's fine. Maybe you're going to think about that in a different way. Maybe you're going to do it like, okay, PE1 is equal to PE1 plus PE2 plus PE3. Oh, sorry, PE2 plus PE4 plus PE6. And what is the chance that you're going to get 2? What is PE2? P little e2. P little e2 is the probability of getting number 2 when you roll the die. What is the chance that you're going to get 2 when you roll the die? It's just 1 out of 6. What is the chance of getting 4 when you roll the die? Is 1 out of 6. What is the chance of getting 6 when you roll the die? Is 1 over 6. So if you add all of these, you're going to get 3 over 6, which is half. So you get the same answer as we did before. So we either use the classical method or we use the rule here, okay? The addition rule. And this is another example. Google has become synonymous with the web searches and is the leader in the search engine marketplace. Suppose officials at the Northern California headquarters have recently performed a survey of computer users to determine how many internet searches individuals do daily using Google. The table shows the result of the survey of internet users and what is the probability that the internet user performs 1 to 9 searches per day. 1 to 9. From 1 to 9. Because we have actually, so this is my event. Event is a user perform 1 to 9 searches per day. Where are 1 to 1? 1 to 9. 1 to 9 equals, basically we're talking about these two little e's. So actually E1 can be written as, this is actually E2 and E3. Right? So you have to find the probability of E1 now. The probability of E1. Using the addition rule, it's equal to the probability of E2 plus probability of E3. What is the chance of E2 occurs? What is the chance that this one will occur? It's 1,900 over the total. So it's 1,900 over 5,000 plus E3 is 1,500 divided by 5,000. You just get these two guys, you add them, then you get the answer. Or you get the ratio for each, then you add them. So we use the addition rule in this case, right? Second one is the complement. The complement of an event is a collection of all possible outcomes not contained in the event E. So the complement is actually 1 minus the probability of event E, the probability of the complement, and we use the bar. The probability of E bar is 1 minus P of E. Example. The managing partner for Capital Consulting is working on a proposal for a consulting project with a client in Sydney. The manager lists 4 possible net profits from the consulting engagement and is subjectively assessed probabilities related to each profit level. What is the probability that the profit will exceed 0? This is my event. The profit will exceed 0. We are asking about the probability of that event. Okay. The event that the probability the profit will exceed 0. So it's not going to be 0. Exceeding 0. Okay, so the probability, look, the probability of profit will exceed 0. It's actually everything other than the 0. So it's the profit is not 0. Is not 0. The profit is not 0 is equal to 1 minus the probability of the profit is 0. Right? You can basically call this one, if the profit is 0, you can call it E1. I used a different color. You can call this one E1. You can call the profit is not 0 is E1 bar. So this is easy because the answer is going to be 1 minus, what is the probability is 0? It's 0.7. We are given the probabilities here. Now, in this example, we are given the outcomes, the probability of the outcome, P of the outcome. So there's no need to divide because we are given the probabilities. So it's 1 minus 0.7, which is 0.3. Someone is going to say, why? Because, the question asks you to find the probability will exceed 0. Why don't we find all of these? You can do this. You can add all of these highlighted in yellow. You're going to get the same answer. But because we have a faster way to do this, the profit will exceed 0. That means the profit is not 0. The profit is not 0. That means 1 minus the probability of the profit is 0. So we use the complement rule, right? So you can do it in both ways. Rule number 4, addition rule for any 2 events. If you have the probability of E1 or E2, that means we have to find the probability of E1, now we're talking about events now, plus the probability of E2, but we have to subtract the common region between these 2 events because we count this twice. If I would like to find the probability of E1, this is E1, the first circle. The second one circle is E2. If you add these 2, that means you count this shaded region twice, so you have to subtract it once. So that's why when you do the addition rule for any 2 events, you have to subtract the common region. However, if the E1, E2 are mutually exclusive or disjoint, or they cannot occur at the same time, then this cannot happen because they cannot occur at the same time. The events cannot occur at the same time. So that's why this is 0. The probability of these occurring at the same time is 0. Basically, this rule, we can say it like this. If the E1 and E2 are disjoint, so E2, they're going to be like this. E1 and E2, they're going to be like that. Okay? So they are disjoints, so they cannot occur at the same time, so the probability that these will be occurring at the same time, which is the end, we use the end, is 0, right? So this is for that one. So if the 2 events are disjoints or mutually exclusive, then the probability of E1 or E2 is going to be only these. You just add both of them. An example. So this is one of the most important rules, by the way, the OR, okay? E1 or E2. Let's continue that example that we started with, the Google example. We need to, or the manager or something, they consider the age as important to in designing their search engine methodologies. That's why they have another improved table, so more data. So in the previous example, we had this table. Now we have another table, right? We now break down the age based on the age, not just the search per day. We did not just put the number, the total number, the frequencies, which is here basically. No, we included the age. We break them into based on the ages, right? So for example, and we call them, these are events, by the way, because now we have more than one variable. We have 2 variables in this case. We have the search per day and we have the age group. We have 2 things. So E1, basically, what is E1? E1 contains the searches per days greater than 10. E2 searches between 3 and 9. E3, 1 and 2 searches. E4, 0 searches. E5, age group under 30. E6, age group between 30 and 50, and so on. So all of these are now events. We have so many events, right? And now I want to say a super important idea now. We have two things. Something we call it joint frequencies and something we call it marginal frequencies. The joint frequencies are the ones that we're going to find them here inside the table. These are joint frequencies. Why these are joint? It's simple because they are joint between, these contains two things, the age group and the search per day. So for example, what is the 200? What does the 200 represent? The 200 represent that people who are doing greater than 10 searches and they are under 30 years old. What is the 900? The 900 is people who are doing between 3 to 9 searches, right, every day, and they are between 30 and 50 years old. So these are numbers in the middle, we call them joint frequencies. However, numbers in the margins outside, we call them marginal frequencies. These are marginal, the blue one, right? Because they're giving you information on only one variable. So for example, what is the 400? 400 is just for the E1, right? For the search, the ones who are doing greater than 10 searches a day or equal, right? So this is for E2, this is for E3, this is for E4, this is for E5, this is for E6, this is for E7. Let me go back here. What about this? This is for E2 and E5. Remember, look, the 600 is for E2 and E5 joint. Make sense? So this is important. These two concepts are super important, so we're going to use them a lot. So if you look at the question now, what we care about, find the probability of a respondent conduct 0 search per day, or, this is a keyword, or his age within 30 to 50 years old. Let's break down this into two things. Look, 0 search, a person 30, 50. We look at the probability. So we look at the probability of what? 0 search. 0 search means what? E4. Or age within 30 and 50. Where's E6? So we can use the rule. What does this mean? It means P of E4 plus P of E6 minus P of E4 and E6. And these two are marginal probabilities. And this is joint probability. That means these two marginal, we're gonna find them from outside the table. We're gonna find the probability. So the question is, let's look at them in details. What is the probability that a person is gonna do 0 searches? So we're gonna look at 4th row. We have 1,200 out of the total, which is 5,000. What is the probability that a person, okay, look, in this one, we ignore the age. We don't look at the age. We just look at the search per day. So we look at the search per day. What is the chance, what the probability that a person is going to make 0 searches? You go to the total, basically. You look at the ones who are doing 0 searches, regardless of the age. There we have 1,200 over the total. We have what? We have 0.24 plus. The second one, we care about the age. We don't care about the searches. So what is the probability that a person is between 30 and 50 years old? We have 2,100 of these guys divided by the total, which is 0.4, regardless of number of the search. This one doesn't say anything about the number of searches, right? Just what is the probability that a person is going to do this, or a person is within this age, between 30 and 50. Minus, so both of the numbers we picked are what? Marginal. Now the joint, minus, what is the probability that a person is, or doing 0 search at the same time, he's between 30 and 50. This one. How many people do we have doing this? 0 search and their age between 30 and 50. We have 500 of them out of the total 5,000. So you have 0.1 basically. So 0.1, and you can see it, by the way. Let me just explain this quickly. When you get the 0.24, basically you're adding all of these to get 0.24. And when you get the 0.42, you're adding all of these to get the 0.42. So that means we're adding the same number twice, this guy twice. Anyway, so the first two are the marginal, the last one is the joint. So when you add the 0.24 and 42, so we get 66, and so this is 56%. Sometimes we need to determine the chances of 2 or more events occurring either at the same time or in succession. This is important. For example, quality manager, control manager for a manufacturing company may be interested in the probability of selecting 2 successive defective products from an assembly line. Or the decision maker might know that the event has occurred already and may then want to know the probability of the second event. So we have sometimes this case. So in this case, we have something, so we call it conditional probability. The conditional probability is the probability that an event will occur given some other event or events have already occurred or happened. So the conditional probability is what? The probability of E1 given that E2 is already occurred. Maybe I'm going to ask you, what is the probability of E2 given that what is the probability of E1 given that E2 already occurred? What we do, we find the joint probability and we divide by the marginal probability, right? Marginal G. Marginal probability. And we have to make sure that PE2 is not 0 because we cannot divide by 0. So joint over the marginal. Now, an internet service provided to rural areas in the Western United States, the company has studied its customers' internet habits. Among the information collected are the data shown in this table. The company is focusing on high-volume users, and one of the factors that will influence its marketing strategy is whether the time spent using the internet is related to a customer's gender. So a marketing analyst needs to know the probability of a person who uses services 20 to 40 hours per month given the user is a female. Now we have the table, and luckily we are given, again, we have two variables now, hours per month. We call them E1, E2, E3. These are events. The other events are female or male, right? So this is E4, E5, right? And remember what we said about these guys. What's inside? These are the joint events, and these are the marginal frequencies, right? The question is, we're asking about what? Let's convert the words into math. We have to find the probability of what? A person uses service between 20 to 40 hours per month. This is my probability. Where is it? Between 20 to 40 is here. It's E2. So the question asks you to find the probability of E2, but the question is not finished yet. He tells you that given the user is a female is E4. So E4. So immediately what you can tell me, oh, this is a conditional probability. You can use a rule. We can find the joint between these two events and E4. And we divide this by E4. Right? This is the probability. Look at the indices. This is important, by the way. Let me erase this. This is E1, this is E2, and now we have E2, the given condition. Okay. And what is the E1 and E4? E1 and E4, and as we said, we're looking for the joint probability. So let's find this first. So before we answer the question, let's find this because it takes time. Probability of E2 and E4 is actually, we look at the number. Where is E2 and E4 crossing one? So 300, right? So 300 divided by what? By 2,500, the total number of people, right? If you divide these two numbers, what we get 0.12, right? Now let's find the probability of E4. Where is E4? This is E4. This is E4. What is the probability of E4? There's a marginal, as we said. So we have 850 of the females out of the 2,500, which is in this case, we have 34%. Now we divide these two numbers. So the probability of E2 given E4 is 0.12 divided by 0.34, right? If you divide them, you get 0.35%. And this is nice, right? Because someone's going to tell me, can we do this a different way? Yes, we can do this a different way. But using the conditional probability, it's just a straightforward. Someone maybe is going to say, how many female do we have? We have 300. And how many, we have 850 female, and how many of those doing between 20 to 40 hours per month is the 300, then we can just divide 300 over 850. Yes, this is correct. So other way of doing this, what is the probability of a person uses service 20 to 40 hours given that she's a female? So you can tell me how many person do we have uses the internet between 20 to 40 hours and she's a female? It's a 300. Out of the total female, which is 850, you're going to get the same answer. So basically, we divided these two guys. Let me use this color. We divide this over this, right? But you have to be careful. You have to understand the concepts behind using these two different methods, because we are looking at the probability of that event among the female. That's why we divide by 850. 20 to 40, we have 300 among the females. How many females do we have? 850, right? Or we do it using the rules, the conditional probability. Okay. In the previous parts, we were able to find the AND probability of E1 and E2 if we know the joint relative frequency tables, right? But sometimes we have to find this, right? But we don't know the joint relative frequency. So we use the independent and dependent rules. Actually, this is a very careful rule that you have to look at it. The probability of E1 and E2 is equal to the probability of E1, look, is E1, times probability of E2 given E1. E2 given E1. So you have to be careful when you write this down. If the events are independent, then the rule becomes like this. It's easy to actually derive this one from out of that one. Okay. So the last example we're going to go over is that one. If you have a fireworks manufacturer company uses two suppliers of material in making a particular product, the materials from the two suppliers are mixed in the manufacturing process, right? When a case of a fireworks is being made, the material is pulled randomly from the inventory regardless to which company made it. Recently, customer ordered two products. This is the point, two products. At the time of assembly, the material inventory contained 3 units of MATX and 50 units of Quinix. What is the probability that both firework products ordered by this customer will have MATX materials? So now we have two events basically. So E1 is going to be what? MATX is first, because we're looking for the probability that both of them having MATX. So the first one is MATX, the first event. Second event, MATX is the second as well. Right? So we have to find the probability that the first one is MATX and the second one is MATX. This is the question, the probability that both of them MATX. And using the rules that we have just explained, this equals to the P of E1 times P of E2 given E1 equals. Now, what is the probability of having the first one to be MATX? The first one is being, we have two of them. We have 30 MATX. We have 50 of Quinix. What is the probability that the first one is going to be from MATX? Is just 30 out of 80, right? Times. What is the chance of that the second one is going to be MATX, given that the first one was already taken, which is the first one was MATX? We have 29 out of 79. That's it. Then we multiply these two numbers to get 0.1377. Because the choice of the second one will actually depends on the choice of the first one, right? So that's why we have a conditional probability here. That's why we use the question asks you to find this. That's why we use this formula. We don't have any other formulas to use. So this is everything. I'm going to leave this example to you. It's straightforward. This is everything about chapter 4.